Hey guys, here we go with an implicit differentiation question. That sounds like a mouthful, so let's talk about what it is. How do we know it's an implicit differentiation question? Well, because there are x terms and multiple y terms. So usually we're just used to seeing a function that is y equals some function with a bunch of x's in it. In this case, you can see we've got a y term, a y squared term, a y cubed term. So those are going to be very difficult to deal with. Trying to get a single y on its own. In fact, it's pretty much impossible, so we use implicit differentiation. It seems like a complicated thing, but all you have to do is treat y's as if they're another function of x and differentiate them the exact same way, except for every time we differentiate a y, we are going to multiply the answer by y prime. So that's why it's another clue. They say find y prime. So again, treat the y terms just like x terms, follow the same power rules, the same product rules, etc. But every time you differentiate it, multiply it by y prime. So let's go through each term. So x cubed. We have four different terms, 1, 2, 3, 4, all separated by positives and negatives, so we know we can just differentiate those and add them back together. So x cubed, we know power rule becomes 3x squared when we differentiate. Now, term 2, we've got an x squared times a y, so we have to do a product rule. Product rule says the derivative of the first, 2x, times the second, normal, plus the derivative of the second. Derivative of y is just 1, but because it's a y term, we multiply by y prime. Y prime times the first. Great. Minus, we now have another product rule. Derivative of the first is x, that's just 1, so 1 times y squared, plus the derivative of the second, 2y, because it's the power rule, but again, because it's a y term, we multiply by y prime times the first. So that was a little bit trickier of a product rule. And the last term is just going to be plus 3y squared. Again, it's a y term, so we multiply by y prime. And it's equal to 0. So we've differentiated everything, but we're still trying to isolate for y prime. So the rule now is get everything on one side with a y prime in it, get everything without a y prime in it on the other side. So I'm going to keep 3x squared over on the left side. I'm going to keep plus 2xy with it because there's no y prime there. I'm going to keep negative y squared from the bracket, and I'm going to keep, that's it. Looks like we have to move everything over to the other side. So that took care of this, this, and this. I'm now going to subtract this term over to the other side. So negative y prime x squared. This negative comes in here, so it was negative 2y y prime x. So I'm going to add it to the other side, so it's positive 2y x y prime. And I'm going to subtract this term over to the other side, so 3y squared y prime. Great, so now we've got this equation, and the reason we bring everything to one side with a y prime in it is so we can factor out a y prime. So I'm just going to factor out. I'm left with negative x squared plus 2yx minus 3y squared. Again, I've just factored out that y prime from every term. The left side remains the same. And to get y prime on its own, I'm just going to divide by that factored bracket. So it will cancel here and divide here. Do the same thing to both sides as always. So we can say y prime equals 3x squared plus 2xy minus y squared all over negative x squared plus 2yx minus 3y squared. Again, implicit differentiation. Treat the y's just as if they're x's. Follow the same power rule, product rule, quotient rule, whatever it may be. But every time you're done multiplying by every time you're done differentiating the y terms, multiply it by a y prime. Then get everything on one side with a y prime so you can factor out and divide. Info@arnoldtutoring.com if you guys have any more questions. Hopefully this helps you with your next implicit differentiation.